All right, so today we're going to quickly go over Chapter 6 or Unit 6 in the Print Reading for Industry text. We are now talking about section views. Now, section views are just a little bit further breakdown, so you have to have a very good understanding of the orthographic views to kind of understand the projection and the way the projections work as we kind of cut out and remove sections from those different types of views that we're looking at. So, of course, learning objectives here, we're going to describe general nature of section views, explain their purposes, identify types of lines. So you should remember that there are three types of lines that are going to be used for this. We're going to identify basic section line patterns. There is material, or different materials are indicated by section lines. So the explanation of characteristics on a drawing that will feature a full section view. We're going to describe the characteristics of a half section view. Now, again, a lot of this becomes terminology heavy, so you've got to understand the terminology that's involved in this unit. So we're going to describe characteristics of an off section view, or an offset section view, sorry. Identify the characteristics of a sectional view that includes aligned features. So a view that features a broken out section. We're going to compare revolved sections and remove sections and identify the characteristics of those sections. Lastly, we're going to explain some of the conventional practices applied to section views, identify the proper representation of parcel sections and outline sections. We'll identify the proper representation of separate parts in an assembly drawing and an assembly section view, and then of course we'll discuss some of the benefits or the ways that computer generated section views can really help us to see and look at parts as a whole. All right, so the section view basically comes where we are cutting an imaginary plane through the object and removing part of that particular part from the from the drawing for the observer. It helps us to see interior features of an object, things that we might need to know and have a little bit more clarity on. Grooves are a big aspect of it, hole patterns, the way things look on the inside, and maybe what we might want to get some more detail on if we were really able to physically break these parts, break the actual object apart. Again, this is part of the Ask Me Why 14.3. So, and that's what the standard is that covers the standard practices on these views. So as we talk about section lines, remember here that the section lines basically show are different patterns, either crisscross patterns or parallel lines that kind of represent the inside or section of a part. They're usually drawn with continuous lines that are about 1/8 of an inch apart and at a 45-degree angle, although that's not always going to be the case, but very frequently they are like that. Now, in drafting, if we were actually board drafting, we would be paying attention to this, and we would keep the pencil that we were using to a nice sharp point to be able to generate that. And today, with most of this being generated by CAD, the CAD programming, the program itself takes care of all of that, so we don't have to worry about it as much as we used to. So cutting plane lines represent edge views of the cutting plane. So when we place they're placed adjacent to that view, and they indicate the direction that we're going to be looking at. So if you take a look at the drawing on the lower right hand side, you can see our cutting plane line here, and it is pointed to the left, which means that when we cut that out, you can see now here are the section lines, and that means we are looking directly at it from the right side view. So the right side of the piece is more or less removed. So when we would not see that, we're just kind of seeing the inside. So you can see from up here in this isometric view, the section, when we're doing this full section here, so we're going to see the section lines here and here. So, and that's the material that's on the inside. And then of course we see that hole. So whereas if we were without the cutting view, we would not see that full hole. So we would see that as a hidden line on the inside. So this gives us a clearer idea of true size and true shape of both of these features now at this point. So the thick line with the arrowheads, of course, is the section view. So, and it's showing and pointing to the viewing direction. So we have different types of section views, and this is what you need to kind of just get these views and the terminology here in your head so that you really fully understand it. So this is what we refer to as a full section view. Now recall, so you kind of have to kind of think about this. A full section view is basically going to cut the part in half. So and as you see up here, this is showing the front and left side view here of a part. So in the top drawing, we're seeing all the hidden lines. We can do a full section view. You can see the hatching here for the section lines, and now we also see the solid object lines for all of the interior components that would be going on there. Note that most the time hidden lines are usually omitted from full section views. Next, we have what's referred to as a half section line, and basically a half section is more or less a quarter section. So this is where it's going to get kind of technical for you to remember. Full section view gives you half a part. A half section view removes a quarter of the part. As some general guidelines. So it's created when when a symmetrical object is drawn with one half of the view as a section, the other half or the other part of it as a regular view, and this cuts halfway through the object. So notice there's only one arrowhead on the cutting plane, but now look at the position here of how this line goes. So it's kind of showing you have the arrowhead pointing that way, it comes down here to the center point of the object and then moves to the right. So and shows you that that is on this level. So we see the full view. So from the bottom, so as we're looking at this way, we would see the outside of the part here and then the inside surface here as well. So you got this kind of showing you again, we would be looking at the isometric from this direction. So you're going to see this part right up here. So is what we're seeing in here. Now, again, this is kind of a useful way to kind of tell some of these interior features. Maybe we want to know more about the radii that's in the corner, or maybe we want to know more about the actual angle or the taper that's in here. So there's several different reasons why we might be using that. The offset section view is next. Now let's take a look at the cutting plane line here. So you can see the two arrowheads here on the cutting plane line. Notice how the cutting plane is offset. So we aren't just going through the center. So it does come through the center at a point, but it starts up here, kind of comes back, goes across in the middle, then it sets back here as well, and then goes out. So what we're seeing as we kind of bring these projections, if we take a look at our cutting plane line and we bring it back, so from about here over, we're seeing the inside wall of the part here. From here all the way over to this side of the part, we're seeing the inside surfaces of the part from here to here, and then from this cutting plane as that comes back to here, we're seeing the inside wall of the part there, and that's what we would refer to as an offset section view. So that is offset at some point. In this case, for some reason, maybe they want to show the interior of the hole pattern and want to let you know that the hole pattern is uh, that way, but at the middle of the part, it's more important to show this. So there's a variety of reasons for that aspect here in terms of what we call an offset section view. Our next view here is an aligned section view. Notice the direction of the arrows, how it's going at an angle. And we would basically be rotating this around. So, and we're seeing the inside again section of this part, and it's used mainly for cylindrical objects that have an odd number of features. So that way we can actually represent and see the inside of those features here as well. Your cutting plane offsets through a feature. It is more or less rotated to normal vertical or horizontal plane and projected onto a sectional view. So this one's probably going to be a little bit harder to kind of understand, because what we're really technically doing here is, if you think about it, we have about 60 degrees from here to here and 30 degrees from here. So what we're technically doing with the aligned section view is this would more or less rotate about 30 degrees this way. So we would be seeing these edge views, and this side would actually be rotated around to help us view the interior of this part. Our broken out section view uses some additional short break lines. So it is again used to show the interior construction and expose some of the parts that we want to see. So this kind of gives you a representation of the isometric. We're more or less just kind of cutting out this part right here so that we can see and view this surface. And again, in this, it's kind of being done to help show us this angle of the hole and how that hole enters and breaks through into the actual bottom surface of this. So it's similar to a half section view, but because we are cutting it out and using a short break line, it's referred to as a broken out section view. Then we have a revolved section view. And again, here in the revolved section view, we're cutting plane along the part. Notice the use of your short break lines here. And then, of course, we rotate that at 90 degrees. In this case, that helps us to be able to identify and see the rib pattern of this particular part. So, and it might be done on both sides just to help further clarify the view. Okay. We also have what is referred to as a remove section view here. So it's similar to the revolve section, except we physically will take that and kind of place it someplace else on the print to actually show it is going to be identified with letters here. So this would be referred to as section AA. Notice then that underneath the remove section view, we will see section AA. It will be labeled section BB. So again, this kind of shows the cutout and the interior view looking from that direction. Now, I'm going to stop at this point. So go back and review the different names of these views, because this is where you're going to get hung up the most, is with terminology on what these views are actually called.